Now let us study the another property, that is the polarizability. It is generally the ability of electron cloud to move or distort. The more attracted the electrons are towards the nucleus, it will be difficult to polarize that electron cloud. Now if we see the general trend across a period, polarizability generally decreases from left to right, because from left to right, if you see, uh, the electrons, they are at the same distance from the nucleus, but due to increase in the atomic number, the nuclear charge will be more and the electrons will be tightly held, so it will be difficult to polarize it. Whereas if you go down the group, there will be increase in the number of energy levels, and the distance of the electron, outermost electron from the nucleus, will be increasing, so it is easy to remove the outermost electron. So as you can see the diagram, polarizability decreases from left to right and across the period, and down the group it increases. Now let us talk about another periodic property, that is the oxidation state, which is nothing but equal to the number of electrons which are present in the outermost orbital, or you can say it is equal to 8 minus number of outermost or valence electrons. So it represents the charge which is possessed by an atom due to loss or gain of electrons. If you see across the period from left to right, the number of valence electron increases. So oxidation state, it ranges between 1 to 8. You can see here I have taken group 1, 2, 13, 14, 15, 16 from left to right. So oxidation number is increasing, and it is also showing variable oxidation state. And if you see from top to bottom, the valence electrons, they remain same, so almost they have same valency, so oxidation state will be 1. Come to the hard and soft acid base concept, also known as the Pearson concept. It is very important and used in chemistry in order to explain the stability of the compounds. Hard generally means one which is less polarizable or weakly polarizable, and these species, they are small, they have high charge state. It is applicable both to acid as well as base. Whereas soft means which is easily polarizable, and they are big, they have low charge state, and they react faster. These are the examples of hard acid and base, soft acid and base, and few which are on the borderline. Let us summarize. The atomic radii decreases from left to right due to increase in the nuclear charge, while the ionization energy, electron affinity and electronegativity, it increases due to the increase in the nuclear charge. And in the group, if you see, the atomic radii increases due to increase in the number of shells, while the ionization energy, electronegativity and electron affinity will show decrease.
Coordination number is the number of ligands which are surrounding the metal ions in a complex. Through coordination number, we can find out the geometry of the complex.
Now let us discuss the geometries based on the coordination number. Let us take the example. Based on coordination number, complexes generally try to attain maximum stability, and they show different geometries based on different coordination number. For example, for 2, generally the geometry is linear, because in that case they will be far apart from each other and they will be having minimum repulsion, thus maximum stability. These are the complexes here shown, which will be showing linear geometry having a bond angle of 180 degree. Now let us come to the coordination number 3. Coordination number 3, generally it shows trigonal planar geometry. It is in terms of hybridization, it will be sp2 hybridized, and it will be showing a bond angle of 120 degree. Now let us come to coordination number 4. It will be showing either tetrahedral or square planar geometry. These complexes, they are showing tetrahedral geometry, and these are the complexes which will be showing square planar geometry. It looks like this. with coordination number 5, generally hybridization which we expect is sp2d2. It is trigonal bipyramidal. For example, this complex, it is showing trigonal bipyramidal geometry. Then coordination number 6, generally hexagonal, planar or regular octahedral you can get, or trigonal prism you can get with this coordination number. These are the examples. This is showing hexagon planar, this is showing you the trigonal prism and the octahedral. These are the complexes which shows this geometry. With coordination number 7, general geometry is capped octahedral or pentagonal bipyramidal. This is the complex example of the complex which is showing pentagonal bipyramidal geometry. And then with coordination number 8, it is dodecahedron, cube or square antiprism. It is shown by this complex, as you can see over here. It is showing this geometry. So what I mean to say is, based on the coordination number, it will be showing different types of geometry.
Let us talk about the molecular geometries. It represents the three-dimensional arrangement of atoms in a molecule. Based on the sp d orbitals involved, there will be different geometries seen in the molecules, and molecules actually they show geometry to show maximum stability. Let us talk about the linear geometry. Example is barium chloride. Now the electronic configuration is 1s2, 2s2. In 2s there are 2 electrons. In the excited state, one of the electron will go to the p orbital, and there will be mixing of orbital. So 2 unpaired electrons are there. Pairing will take place with chlorine. So it is showing S and P, sp hybridization. The geometry will be linear. It is having a bond angle of 180 degree. Now let us come to the trigonal planar geometry. Example is BCl3. It is having a total 5 electrons. So outermost electron will be this 3, which we will consider. In excited state, one of the electron it will go here, and mixing of orbital will take place. 1s and 2p orbitals, they will get mixed, and resulting in sp2 hybridization. Pairing will take place with 3 chlorine, and the structure will be trigonal planar structure. It will be showing a bond angle of 120 degrees.
Now let us talk about the tetrahedral geometry. In case of methane, if you see, it is having total 6 electrons. Outermost electron is 2s2 and 2p2. So 2s2, 2p2 I have taken. In excited state, one of the electron will go to the p orbital. There will be mixing of orbitals, 1s and 3p orbital, resulting in a formation of new hybrid 4sp3 hybrid orbitals, and pairing will take place with the hydrogen. So it will be sp3 hybridization. Structure will be tetrahedral. Now let us go to the trigonal bipyramidal structure. PCl5, 15 electrons. So outermost electron will be 3s2, 3p3, 3s2, 3p3, and 3d will be vacant. In excited state, one electron will go to the d orbital. So as a result, this 5sp3d hybrid orbitals will be formed, and it will be showing trigonal bipyramidal structure. Now let us come to the octahedral geometry. SF6, it is having total 16 electron. Outermost electron will be 3s2, 3p4. So 2 electrons, they will jump to 3d orbital. So total there will be 6 orbitals having unpaired electron. There will be mixing, resulting in the formation of 6 sp3d2 hybrid orbitals, and that will result in octahedral geometry. In case of water and ammonia, it shows a different structure. It is having sp3 hybridization, but structure is not tetrahedral. That is due to the presence of lone pair of electrons. So oxygen have 4 valence electron. This I have shown. Now in this, 2 will be lone pair, will not take part in bond formation, and 2 will be bond paired. So it will be sp3 hybridization with 2 lone pair of electrons, due to which it shows a band structure, and bond angle will be 104.5.
Now let us talk about ammonia. In ammonia also, if you see the configuration, outermost electron is 2s2 2p3. So this I have written. It is having one lone pair of electron and it is showing sp3 hybridization, but structure will not be tetrahedral. It is again bent due to the presence of lone pair of electron. Now seesaw structure, if you see in case of SF4, it is having total 6 valence electron, 3s 3p. They are taking this 6 valence electron. Now one electron, it will get excited to the d orbital. Still it is having one lone pair of electron, due to which it shows a seesaw geometry. Now let us come to ClF3. It is showing you T-shaped structure. 17 electrons are there. Outermost 7 electrons are there, occupying 3s and 3p orbital in the excited state. If you can see one of the electron, it will go to the d orbital. Still 2 lone pair of electrons are there, due to which it will show distortion, and it is showing you the T structure.